Hi there, and thanks for being here. Over the next little while, we're going to take a slow journey together, out past the familiar planets, beyond the orbits of the giants, all the way to the distant, quiet world of Pluto. There's no rush. Nothing to prepare for. Just settle in, get comfortable, and let yourself drift along with me. This is a place where time moves differently. Where the sun is just another star in the sky. Where silence stretches across billions of miles, and the cold is so profound it's almost peaceful. We'll be traveling aboard a spacecraft, gliding gently through the dark. I'll share some things about Pluto, facts, observations, little details that might help you picture this faraway place. And then, when the talking is done, I'll leave you with just the soft hum of the ship, so you can rest, or sleep, or simply be still. There's nothing you need to do. Just listen, or don't. Close your eyes if you'd like. Let your breathing slow. We're already on our way. The spacecraft moves without sound, at least not the kind you'd hear in open space. But inside, there's a faint hum, the low vibration of systems maintaining themselves, keeping us alive, keeping us moving. It's steady, constant, almost comforting. Out here, the sun is small. If you were to look at it through the window, it would seem no larger than a bright star, nothing like the blazing disk we see from Earth. It still provides light, technically, but it's a pale, distant light. The kind that barely warms anything. The kind that makes you realize just how far we've come. We're almost 40 times farther from the sun than Earth is. That distance is hard to comprehend. If you could somehow drive a car toward Pluto at highway speed, never stopping, it would take you more than 6,000 years to arrive. Light itself, traveling at 186,000 miles per second, takes more than 5.5 hours to reach this far. We've been traveling for years to reach this point. Years of silence, of slow acceleration, of patient waiting. And now, finally, Pluto is ahead of us. It's not much to look at from a distance. A faint dot. Grayish, maybe slightly tan. It doesn't shine like the gas giants do. It doesn't have rings or storms or glowing auroras. It's just there. Quiet. Unassuming. But as we get closer, details begin to emerge. Pluto is smaller than Earth's moon. If you stood it next to our moon, Pluto would be noticeably less imposing. It's only about 1,400 miles across, roughly 2/3 the width. To put that in perspective, it's smaller than the United States is wide. You could fit Pluto comfortably between New York and Denver, with room to spare. And yet, despite its small size, it has its own moons. 5 of them, in fact. The largest, Charon, is so big compared to Pluto that some scientists think of them not as a planet and moon, but as a binary system, 2 objects locked in a slow dance around a shared point in space. Charon was discovered in 1978 by an astronomer named James Christie. He was examining photographic plates of Pluto when he noticed a slight bulge that appeared periodically. At first, he thought it might be a defect in the images. But the bulge was consistent, regular. It moved. Eventually, he realized he was seeing a moon. He named it Charon, after the ferryman in Greek mythology who carried souls across the river Styx to the underworld. It seemed fitting, given Pluto's namesake, the Roman god of the underworld himself. Charon is about 750 miles across, just over half of Pluto's diameter. It orbits at a distance of roughly 12,000 miles, which in cosmic terms is very close. The two are so close, in fact, that the center of gravity they orbit around isn't inside Pluto, it's in the space between them. Charon is always in the same spot in Pluto's sky. If you were standing on the surface of Pluto and looking up at Charon, it would never rise or set. It would just hang there, unmoving, day after day, year after year. A constant companion. And the same is true in reverse. If you stood on Charon and looked up, Pluto would be frozen in your sky, never moving, always there. The other moons are much smaller. Styx, Nix, Kerberos, and Hydra. They were all discovered much later, in the 2000s, using the Hubble Space Telescope. These tiny moons are irregular, tumbling chaotically through space. Their rotations are unpredictable, their orbits wide and tilted. They're probably fragments, leftover debris from some ancient collision that happened billions of years ago, back when the solar system was still young and violet. The largest of these smaller moons, Hydra, is only about 34 miles across at its longest point. Nix is slightly smaller. Kerberos and Styx are smaller still, just a few miles wide. From Pluto's surface, they would look like faint stars, barely visible, drifting slowly across the sky. But now, everything is still. We're approaching Pluto from the sunlit side, and as we get closer, the surface begins to resolve into shapes. There are plains here. Mountains. Craters. All of it bathed in that dim, distant sunlight. The most striking feature is a large, heart-shaped region. It's lighter in color than the surrounding terrain, almost pale, made of frozen nitrogen, carbon monoxide, and methane. Scientists named it Tombaugh Regio, after Clyde Tombaugh, the astronomer who discovered Pluto back in 1930. Tombaugh was only 24 years old when he found Pluto. He was working at Lowell Observatory in Arizona, systematically photographing sections of the night sky, looking for a predicted ninth planet. He would take 2 photographs of the same region, separated by several days, then compare them using a device called a blink comparator, which rapidly switched between the 2 images. Stars would stay in the same place. But anything moving, a planet, an asteroid, would jump. On February 18, 1930, Tombaugh noticed something. A tiny point of light that shifted position between photographs. It was faint, slow-moving, far away, but it was real. He had found Pluto. News of the discovery spread quickly. The world was captivated. Here was a new world, at the edge of the known solar system, mysterious and distant. The task of naming it fell to the observatory's staff, and suggestions poured in from around the world. The name Pluto was suggested by Venetia Burney, an 11-year-old girl from Oxford, England. She had been learning about Greek and Roman mythology, and when her grandfather told her about the new planet, she thought Pluto, the god of the underworld, dwelling in darkness, seemed appropriate for such a distant, cold world. The name was perfect. The astronomers agreed. And so Pluto it became. Within that heart-shaped region is a smooth plain called Sputnik Planitia. It's one of the most geologically interesting places we've found in the outer solar system. There are no craters there. Not a single one. That tells us something important. This surface is young. In cosmic terms, anyway. Maybe just a few million years old, perhaps even less. Something has erased the ancient scars, maybe slow-moving glaciers of nitrogen ice, maybe convection currents beneath the surface, like a lava lamp made of frozen gas. The ice here flows. Slowly. Imperceptibly. Over thousands of years, the nitrogen ice softens, rises, spreads, and sinks again, constantly reshaping itself. Scientists studying images from the New Horizons spacecraft notice patterns on the surface of Sputnik Planitia, irregular polygons, each one about 10 to 25 miles across, outlined by shallow troughs. These are convection cells. Deep below the surface, warmer ice slowly rises. When it reaches the top, it spreads outward, cools, and then sinks back down at the edges. It's the same process that happens in boiling water or in Earth's mantle beneath the tectonic plates. Except here, it happens over millennia, not minutes. It's a kind of motion so gradual that if you stood on the surface and watched for your entire lifetime, you'd see nothing change. But it's happening. Constantly. Silently. Around the edges of Sputnik Planitia, there are mountains. Tall ones. Some reaching 2 or 3 miles high. They're made of water ice, which out here, at these temperatures, is as hard as granite. Water ice is the bedrock of Pluto. The foundation. Nitrogen and methane are softer, more volatile, but water ice, that stays solid. That holds everything up. One range of mountains near the edge of the heart is called Norgay Montes, named after Tenzing Norgay, one of the first 2 people to reach the summit of Mount Everest. Another range is called Hillary Montes, after Edmund Hillary, Norgay's climbing partner. These mountains rise abruptly from the plain, their peaks sharp and jagged, suggesting they're relatively young in geological terms. How do ice mountains form on a world as cold and distant as Pluto? Scientists believe it has to do with the way Sputnik Planitia formed. The plain itself sits in a large basin, possibly created by an ancient impact. Over time, nitrogen ice accumulated there, forming a thick, heavy layer. This weight may have caused the surrounding water ice crust to buckle and fracture, pushing up blocks of ice to form mountains. The mountains have no names that most people would recognize. They're just labeled, peaks and ridges mapped by a spacecraft that flew past only once, briefly, capturing as much as it could before continuing on into the dark. That spacecraft was New Horizons. It launched from Earth on January 19, 2006, atop an Atlas V rocket. It was the fastest spacecraft ever launched at the time, leaving Earth at a speed of over 36,000 miles per hour. Even at that speed, it took 9.5 years to reach Pluto. For most of that journey, New Horizons was hibernating. Its systems powered down to conserve energy, waking only periodically to check in with Earth and adjust its course. The spacecraft was about the size of a grand piano, weighing roughly 1,000 pounds. It carried 7 scientific instruments, cameras, spectrometers, particle detectors, everything needed to study Pluto in the brief time it would have. New Horizons reached Pluto on July 14, 2015, after a journey of more than 3 billion miles. It didn't stop. It couldn't. It was moving too fast, and there was no way to slow down. Carrying enough fuel to break into orbit around Pluto would have made the spacecraft too heavy to launch in the first place. So it flew past at over 30,000 miles per hour, cameras pointed, instruments recording, gathering data for just a few precious hours before Pluto shrank back into a dot behind it. But in those few hours, it changed everything we thought we knew. Before New Horizons, Pluto was just a blurry smudge in our best telescopes. A mystery. A question mark at the edge of the solar system. We didn't know if it had an atmosphere, or what its surface looked like, or whether it was geologically dead or somehow still active. Even the Hubble Space Telescope, orbiting above Earth's atmosphere, could only resolve Pluto as a fuzzy disk with some vague light and dark patches. Scientists made maps based on these observations, but they were rough, uncertain. Now we know. Pluto has a thin atmosphere, made mostly of nitrogen, with traces of methane and carbon monoxide. It's not thick enough to breathe, not even close. The atmospheric pressure at Pluto's surface is about 100,000 times less than Earth's. That's almost a vacuum. But it's there. A delicate haze that extends high above the surface, scattering the faint sunlight into soft blue layers. When New Horizons looked back at Pluto, with the sun behind it, it saw those layers glowing, a faint blue halo, stretching up to nearly 100 miles above the surface. More than 20 distinct layers were visible, probably caused by atmospheric waves, like ripples in a pond. The atmosphere is slowly escaping. Pluto's gravity is weak, only about 6% of Earth's gravity. That's not enough to hold onto the atmosphere tightly. Nitrogen molecules drift upward, reach the top of the atmosphere, and then simply float away into space, carried off by the faint pressure of sunlight and the solar wind. Scientists estimate that Pluto loses somewhere between 300 to 1,000 tons of nitrogen every hour. That might sound like a lot, but Pluto has been losing atmosphere at this rate for billions of years, and it still has some left. There must be a source replenishing it, nitrogen ice on the surface, sublimating into gas. The temperature on Pluto is around negative 230 degrees Celsius. That's negative 380 Fahrenheit. Cold enough that nitrogen, which on Earth is a gas we breathe, freezes solid. Cold enough that methane forms frost. Cold enough that the atmosphere itself can freeze and fall as snow, only to sublimate back into gas when Pluto's elliptical orbit brings it slightly closer to the Sun. And that orbit is unusual. Pluto doesn't circle the Sun in a neat, round path like Earth does. Its orbit is stretched, elliptical, tilted. At its closest approach to the Sun, called perihelion, Pluto is about 2.7 billion miles away. At its farthest, called aphelion, it's nearly 4.6 billion miles away. That's a huge difference. And it means Pluto's environment changes dramatically over the course of its year. Sometimes it's closer to the Sun than Neptune. Sometimes it's much farther out. Right now, Pluto is moving away from the Sun, slowly receding, and as it does, its atmosphere is beginning to freeze. In a few decades, most of it will collapse onto the surface as frost, and Pluto will become even quieter than it already is. The last time Pluto was at perihelion was in 1989. It won't be that close again until the year 2237. A year on Pluto lasts 248 Earth years. If you were born on Pluto, you'd have to live almost 250 years to celebrate your first birthday. But for now, the atmosphere is still there. Thin, cold, but present. As our spacecraft drifts closer, we can see the texture of the surface in more detail. There are regions covered in reddish-brown material, organic compounds called tholins, formed when ultraviolet light from the Sun strikes methane in the atmosphere, breaking it apart and allowing the fragments to recombine into complex molecules. These tholins drift down like snow, settling onto the ice, staining it rust and amber. The word tholin comes from a Greek word meaning muddy. They're not alive, but they're complex, carbon-based molecules that, under the right conditions, could be precursors to life. On Pluto, they're just pigments, coloring the surface. There are ridges that look almost like snakeskin, long, aligned patterns that suggest the ice has been stretched and compressed over time. There are pits that might be sublimation features, places where ice has evaporated directly into gas, leaving behind hollows and depressions. One particularly strange area is covered in what scientists call bladed terrain. These are tall ridges of methane ice, standing on edge like rows of knife blades, all aligned in the same direction. They can be hundreds of feet tall, separated by deep troughs. They're found in the equatorial regions of Pluto, and they're unlike anything seen anywhere else in the solar system. Scientists think these blades form through sublimation. Methane ice evaporates in some areas more than others, carving out the valleys and leaving the ridges behind. Over millions of years, the landscape is slowly sculpted into these eerie, repeating patterns. And there are craters. Not many, especially compared to other worlds, but some. Evidence of ancient impacts, from back when the solar system was more crowded, more chaotic. Most of those craters are old, softened by time and ice. A few look sharper, more recent. One crater stands out. It's called Burney Crater, named after Venetia Burney, the girl who suggested Pluto's name. The crater is located in the southern hemisphere, about 100 miles across, with a bright central peak. It's one of the few large craters visible on Pluto, a reminder that even in this distant, quiet place, impacts still happen. One of the things that surprised scientists most about Pluto was how diverse it is. For such a small, distant world, it has an astonishing variety of terrain. There are smooth plains and jagged mountains. There are dark streaks and bright patches. There are places where the ice looks fresh, and places where it looks ancient. It's a world that refuses to be simple. West of the heart-shaped region, there's a dark, cratered area informally called Cthulhu Regio. It's covered in those reddish-brown tholins, giving it a mottled, almost mottled appearance. The contrast between bright Sputnik Planitia and dark Cthulhu Regio is striking, one side fresh and smooth, the other old and weathered. Scientists believe Cthulhu Regio is ancient, perhaps billions of years old. The dark color comes from tholins that have been accumulating on the surface for eons, never disturbed, never erased by geological activity. There are also dunes on Pluto. Yes, dunes. Not made of sand, like on Earth or Mars, but made of methane ice grains. They're found along the boundary between Sputnik Planitia and the surrounding highlands. Somehow, despite the thin atmosphere, winds on Pluto are strong enough to move small particles of ice, piling them into dunes that stretch for miles. It's hard to imagine wind on a world this cold, this distant. But it's there. Faint currents in the nitrogen atmosphere, flowing from the plains to the mountains and back again, shaped by temperature differences and the slow turning of Pluto beneath its sky. Charon, Pluto's largest moon, is visible now, hanging in the distance. It's about half the size of Pluto, and its surface is different. Darker. More heavily cratered. There's a reddish patch near its north pole, thought to be methane that escaped from Pluto, drifted to Charon, and froze there, then was transformed by sunlight into reddish tholins. Charon has canyons. Deep ones. Some stretch for hundreds of miles, cutting across its surface like scars. One canyon system, called Serenity Chasma, is longer and deeper than Earth's Grand Canyon. It runs for more than 1,000 miles across Charon's equator. These canyons might have formed long ago, when Charon's interior was still warm, still settling, and the surface cracked as it cooled. Or they might have formed when Charon's orbit around Pluto changed, creating tidal stresses that fractured the crust. Charon's southern hemisphere is smoother, less cratered, suggesting it was resurfaced at some point in the past. Scientists aren't sure how. There's no evidence of current geological activity. But something happened. Perhaps ancient cryovolcanism, eruptions of water or ammonia slush from the interior, flowing across the surface and freezing smooth. Pluto and Charon are tidally locked. They always show the same face to each other. This happens when two objects orbit close together for long enough. Tidal forces, the gentle tug of gravity, slowly synchronize their rotations until they match their orbital periods. It took millions of years, but eventually, Pluto's rotation slowed until one day lasted exactly as long as Charon's orbit. And the same thing happened to Charon. Now they turn together, locked in eternal mutual gaze. Together, they orbit a point in space between them, called the barycenter. Neither is truly the center. They're partners, moving together through the dark. If you were standing on the near side of Pluto, the side facing Charon, you'd see the moon hanging in your sky, never moving, never setting. If you walked to the opposite side of Pluto, Charon would disappear below the horizon, and you'd never see it. Half of Pluto experiences eternal Charon rise. The other half never sees it at all. The same is true from Charon's surface. Stand on the near side, and Pluto fills your sky, enormous, 3 times wider than the moon appears from Earth. Walk to the far side, and Pluto is gone. The spacecraft continues forward, and Pluto grows larger in the window. Soon, we'll pass it. We won't land. We won't orbit. We'll just glide by, the way New Horizons did, capturing what we can, observing, recording, and then moving on. Out here, at the edge of the solar system, time feels different. A year on Pluto lasts 248 Earth years. A single day, one full rotation, takes about 6.5 Earth days. Everything is slower. Stretched. The rhythms of this place are not like the rhythms we know. If you were standing on Pluto's surface, the sun would rise and set only once every 6.4 days. But the sun wouldn't look like the sun you know. It would be a bright star, brighter than any other star in the sky, but still just a point. No disk. No warmth. Just a sharp, brilliant light casting long, faint shadows across the ice. At noon on Pluto, the sunlight is about 1/600th as bright as noon on Earth. Bright enough to read by, if you had a book and could survive the cold. Bright enough to see your surroundings, the ice and mountains and plains, all bathed in that pale, ghostly light. But it would feel empty. Quiet. The sky would be black, even during the day, because there's no thick atmosphere to scatter the light and turn it blue. Stars would be visible all around the sun, filling the sky with constant, unwavering points. And beyond Pluto, there's more. Much more. This is the Kuiper Belt, a vast region of icy bodies that extends far beyond Pluto's orbit. Thousands of objects, maybe millions, slowly orbiting the sun in the cold and dark. Pluto is just one of them. The largest we've visited, but not the only one. There are others out there. Eris, Makemake, Haumea, distant, frozen, waiting. Eris is actually slightly more massive than Pluto, though a bit smaller in diameter. It orbits much farther out, taking 560 years to complete one orbit around the Sun. Its discovery in 2005 is part of what led to Pluto being reclassified. For 76 years, from 1930 to 2006, Pluto was considered the 9th planet. Children learned it in school. Textbooks listed 9 planets. But as telescopes improved, astronomers began finding more and more objects beyond Neptune. objects similar in size to Pluto, objects in similar orbits. The question became unavoidable: if Pluto is a planet, are these other objects planets too? Where do we draw the line? In 2006, the International Astronomical Union met to decide. After much debate, they created a new definition of planet. To be a planet, an object must orbit the Sun, be massive enough for gravity to make it round, and have cleared its orbit of other debris. Pluto met the first two criteria, but not the third. It shares its orbital neighborhood with thousands of other Kuiper Belt objects. It hasn't cleared its orbit. So Pluto was reclassified. Not as a planet, but as a dwarf planet, a new category created specifically to include Pluto, Eris, and others like them. The decision was controversial. Many people felt attached to Pluto as the ninth planet. It had been part of the family for so long, and it seemed arbitrary, somehow, to change the rules. But the reclassification didn't change Pluto itself. It's still the same world. Still fascinating. Still worth studying. Still beautiful in its own cold, distant way. And when New Horizons flew past in 2015, it carried some of Clyde Tombaugh's ashes. The man who discovered Pluto got to visit it, in a sense, 85 years later. The spacecraft begins to pass Pluto now. The world slides slowly beneath us, its mountains and plains and craters drifting by in silence. Charon hangs in the distance, watchful. The other moons are scattered points of light, too small to see as anything but stars. There's something humbling about being here. About seeing this place with your own eyes, even if only in your mind. For most of human history, we didn't even know Pluto existed. 100 years ago, it was just empty space. 50 years ago, it was a dot in a telescope. Now, we've seen its mountains, its glaciers, its blue sky. And then, gradually, Pluto begins to shrink behind us. We're moving on, out into the deeper dark, out toward the edge of everything. Beyond the Kuiper Belt lies the Oort cloud, a sphere of comets surrounding the solar system, stretching halfway to the nearest star. We've never seen it. We've only inferred its existence from the comets that occasionally fall inward, drawn by gravity, becoming visible as they heat up near the Sun. The Oort cloud extends perhaps a light year from the Sun, maybe more. It's the true edge of the solar system, the boundary between our Sun's domain and the true emptiness of interstellar space. New Horizons is heading there now. After Pluto, it flew past another Kuiper Belt object, a small, reddish body called Arrokoth. Then it continued outward. It's still transmitting data back to Earth, though the signal is faint and takes hours to arrive. Someday, its power will run out. Its instruments will go dark. And it will drift in silence, a message in a bottle, carrying images of Earth and sounds and greetings in human languages, traveling forever through the void. Pluto is a threshold, a marker, a place that reminds us how large the universe is and how small we are within it. But there's something calming about that, something peaceful. Out here, there's no urgency, no deadlines, no noise. Just the slow movement of ice and rock, the faint glow of a distant sun, and the endless, patient turning of orbits that have repeated for billions of years and will continue for billions more. Nothing we do matters to Pluto. It doesn't know we're here. It doesn't care. It will continue its slow orbit, its mountains will continue to stand, its ice will continue to flow, long after we're gone. And there's a strange comfort in that. In knowing that some things are simply beyond us. Beyond our control, beyond our influence. We can observe, we can wonder, we can appreciate, but we can't change it. And we don't need to. Our spacecraft begins to leave Pluto behind now. The heart-shaped region fades. The mountains blur back into texture. Charon recedes. Soon, Pluto will be a dot again. Then nothing. Just a memory. But for a moment, we were there. We saw it. We drifted through the cold and the quiet, and we witnessed a place that most of humanity will never see. And now, It's time to rest. The narration is ending now. In a moment, there will be only the soft hum of the spacecraft, the faint vibration of systems, the gentle, unchanging sound of motion through the void. You don't need to do anything. You don't need to think about anything. Just let yourself drift. Pluto is behind us now. The sun is far away. The stars are scattered across the black, and none of them are moving. Everything is still. Your breathing is slowing. Your body is settling. The weight of the day is lifting. You're safe here, floating, suspended between worlds. There's nothing to hold on to, nothing to solve, nothing to worry about. Just the quiet, just the hum. Let it carry you. Let yourself go. Sleep now.